Hello student, welcome to your chemistry lab. Today I am discussing the chapter of equilibrium of question paper of February and March phase 1 and phase 2 question paper and solution in Jee Main 2021. And this chapter, one direct question was coming in every year from this chapter and two or more indirect question was coming from this chapter. So read this chapter very carefully. I hope this video will be helpful to you for analysis of identification of topics of this chapter. So I will be request to everyone, please continue to watch up to end and your concept application power will be grow for higher ranking score. So we are watching the whiteboard. Section A, question number 1. The solubility of AgCN in a buffer solution of pH equals to 3 is X. The value of X is Ksp of AgCN are given, Ka of HCN are given, and option are also given. And this question was set in 2021, 25th February, page 1, morning shift, and its answer is 2. We know that the AgCN dissociate Ag plus Cn negative, and Cn negative react with H3O positive form HCN and water. Let the solubility of AgCN equals to X molar and HCN plus H2O form H3O positive plus Cn negative. And we know that the Ka equals to Cn into concentration of Cn negative and H3O positive by HCN, and HCN by Cn equals to 1.6 into 10 to the power 6. We know that the pH equals to 3, means minus log H3O positive equals to 3, then concentration of H3O positive equals to 10 to the power minus 3. So X equals to concentration of Ag equals to Cn negative plus HCl, and Ksp equals to concentration of Ag plus into Cn negative. So X equals to 1.9 into 10 to the power minus 5 molar. So option 2 is a right answer. And next question. Question number 2. The solubility of calcium hydroxide in water is, option are given, and solubility product of calcium hydroxide in water equals to 5 into 10 to the power minus 6. And this question was set in 2021, 25th February, page 1, evening shift, and answer is 3. Solubility, let the solubility be of calcium hydroxide is S in water. So we know that the calcium hydroxide dissociate from Ca2 positive plus 2OH negative. So solubility S and 2S, and Ksp equals to concentration of Ca2 positive into OH negative whole square. And so S into 2S square equals to 4S cube. So putting the all value and gives S equals to 1.11 into 10 to the power minus 2. So option 3 is a right answer. And next question. Section B, question number 1. The stepwise formation of CuNH3 whole for 2 positive is given below, and the value of stability constant K1, K2, K3 and K4 are 10 to the power 4 and 1.58 into 10 to the power 3 and 5 into 10 to the power 2 and 10 to the power 2 respectively. The overall equilibrium constant for dissociation, of CuNH3 whole 4 is X into 10 to the power minus 12. The value of X is, and this question was set in 2021, 24th February, page 1, morning shift, and answer is 1. We know that the Kf equals to Kf of CuNH3 whole 4 2 positive equals to Ka K1 into K2 into K3 into K4. So dissociation constant equals to 1 by Kf. So value is 1 into 10 to the power minus 12. So answer is 1. So next question number 2. The solubility of PbI2 is 8.08 into 10 to the power minus 9. The solubility of lead iodide in 0.1 molar solution of lead nitrate is x into 10 to the power minus 6 mole per liter. The value of x is, and this question was set in 2021 24th February, page 1 evening shift, and answer is 141. Lead iodide PbI2 first dissociate Pb2 positive plus 2 I negative, and then Ksp equals to are given 8 into 10 to the power minus 9, and lead nitrate dissociate Pb2 positive plus 2 NO3 negative. So we know that the Pb2 positive concentration of Pb2 positive equals to 0.1, and then from Ksp of PbI2 equals to Pb2 positive I negative the square equals to 8 into 10 to the power minus 9. So I negative the square, then square equals to 8.0 into 10 to the power minus 8. So I negative equals to 2 root 2 into 10 to the power minus 4. So solubility in PbI2 in 0.1 molar lead nitrate solution equals to 141 into 10 to the power minus 6 molar. So next question number 3. A homogeneous ideal gas reaction AB2 gives A plus 2B is carried out in 25 liter flux at 27 degrees centigrade. Initial amount of AB2 was 1 mole and the equilibrium pressure was 1.9 atm. The value of Kp is x into 10 to the power minus 2. The value of x is dash, and this question was set in 2021 26 February, page 1 morning shift, and answer is 72. First, AB2 gives A plus 2B. Reaction are given. At initial T equals to 0, AB2 number of moles equals to 1, and A and 2B equals to 0, 0. And at equilibrium, 1 minus alpha, alpha is degree of dissociation, and A is alpha, and 2B equals to 2 alpha. So total number of moles equals to 1 plus 2 alpha. And we know that the Pb equals to nRT. So N equals to total number of moles 1 plus 2 alpha equals to Pb by RT, putting the all value, and N equals to 1.93, and here alpha equals to 0.465, and partial pressure, we know that the mole fraction into total pressure. So putting the all value, and AB2, PA and PB are calculated, and so Kp equals to 72 into 10 to the power minus 2. So answer is 72. And next question. Question number 4. The pH of ammonium phosphate solution if pKa of phosphoric acid is, if pKa of phosphoric acid and pKb of ammonium hydroxide are 5.23 and 4.75 respectively, is dash. And this question was set in 2021 26 February, page 1 evening shift, and answer is 7. Ammonium phosphate NH4 whole 3 PO4 is a salt of weak base and weak acid. So pH is independent of concentration of salt, because here two acid and base are weak. So pH equals to, we know that this formula half pKw plus half pKa minus half pKb. So putting the all value and answer is 7.24 and round figure is 7. So answer is 7. Question number 5. Two salt A2X and MX have the same value of solubility product of 4.0 into 10 to the power minus 12. The ratio of their molar solubilities, that is SA2X by SMX, equals to dash, and answer a round figure. And this question was set in 2021 16th March, page 2, morning shift, and answer is 50. First compound for A2X, first dissociate 2A positive plus X2 negative. Here solubility for A2X is S1, and so 2S1 and S1. And KSP of A2X equals to A positive the square and X2 negative, so 4SQ1, so equals to 4.0 into 10 to the power minus 12. So S1 equals to 10 to the power minus 4. For MX and same procedure, S2 equals to 2 into 10 to the power minus 6. So ratio is 10 to the power minus 4 by 2 into 10 to the power minus 6, so equals to 50. So answer is 50. And next question number 6. H2SO3 has pKa equals to 1.7 into 10 to the power minus 2 and Ka2 equals to 6.4 into 10 to the power minus 8. The pH of 0.588 molar H2SO3 is, and this question was set in 2021 16th March, page 2, evening shift, and answer is 1. Ka1 of H2SO3 very greater than Ka2 of H2SO3. The concentration of H plus ion from second dissociation of H2SO3 can be neglected. So we know that Oswald dilution law. So Ka equals to C alpha square by 1 minus alpha. So here alpha equals to 0.156 and pH equals to concentration of minus log H plus ion. Here H plus ion concentration equals to C alpha. So all value are putting and answer is 1. So answer is 1. And next question number 7. 0.1 moles of a weak acid HA, Ka equals to 2.0 into 10 to the power minus 6 is dissolved in 1 liter of 0.1 molar HCl solution. The degree of dissociation of HA is dash into 10 to the power minus 5. And this question was set in 2021 17th March, page 2, morning shift, and answer is 2. HA first dissociate H plus A minus, and initial concentration of HA equals to 0.01 molar and H plus concentration is 0.1 molar are given. At equilibrium, we know that the Oswald dilution law or equilibrium concept, and 0.01 minus X and 0.1 plus X and X. Here approx value is 0.01 molar for HA and 0.1 molar for H plus concentration. We know that the Ka equals to product by reactant, so all value are putting, and so X equals to 2 into 10 to the power minus 7 and alpha equals to X by 0.01, so 2 into 10 to the power minus 5. So answer equals to 2. And next question. Question number 8. Consider the reaction N2O4 gives 2NO2 and the temperature at which Kc equals to 20.04 and Kp equals to 600.1 is dash. Here calculate the temperature, and this question was set in 2021 17th March, page 2, evening shift, and answer. Here answer equals to 354 and N2O4 gives 2NO2. We know that the del N equals to product coefficient of product minus coefficient of reactant, so 2 minus 1 equals to 1, we know that the Kp equals to Kc into RT to the power del n. Here del n equals to 1, so all value are putting, and T equals to 353.99, and so round figure is 354 Kelvin. So next question number 9. In order to prepare a buffer solution of pH 5.74, sodium acetate is added to acetic acid, and if the concentration of acetic acid in buffer solution is 1.0 molar, the concentration of sodium acetate in buffer is dash, and here pKa of acetic acid equals to 4.74, and this question was set in Jee Main 2021 18th March page 2 morning shift, and answer is 10. For acidic buffer of CH3COOH and CH3COO negative, we know that the Henderson equation pH equals to pKa plus log salt by acid, and putting the all value, and here x equals to 10. So answer equals to 10. And next question. 10. The gas phase reaction 2A arrow A2 at 400 Kelvin has del G0 equals to plus 25.2 kilojoule per mole. The equilibrium constant Kc for this reaction is dash into 10 to the power minus 2. Here this question was set in 2021 18th March page 2 evening shift, and answer is 166. We know that given reaction 2A arrow A2 del G0 equals to plus 25.2 kilojoule per mole, and del G equals to minus RT ln Kp, putting the all value Kp equals to 5 into 10 to the power minus 4. We know that the Kp equals to Kc into RT del n, here del n equals to minus 1, and so Kc equals to 166 into 10 to the power minus 2. So answer is 166. And thank you. I think you are enjoy to watch my video. I think you are continue watching my video without skip up to end. I will be come back with the next chapter. So thank you everyone. Bye bye.